Hello students, in this video we are going to talk about fundamental particles of an atom, and we know there are mainly three fundamental particles of an atom: electron, proton and neutron. So we will talk about some information regarding this electron, proton and neutron here. Let us start with the electron, or nothing but the cathode rays. Right. First of all, this electron is discovered by J.J. Thomson. It is discovered by J.J. Thomson. And if you observe carefully, I have mentioned here cathode rays. So why we can call it this as a cathode rays means, so these rays are moving from the cathode to anode, but these rays are not generated by the cathode. Okay, these things you clearly observe. These rays are moving from cathode to anode, but these are not generated by the cathode. These are not generated by cathode. Right. Another information regarding this, if you see, charge of electron, nothing but charge of electron, it is a minus 1.6 into 10 power minus 19 coulombs. So it is a charge of electron. And if you observe here, 1 mole of electron charges, 1 mole of electrons means how many electrons? Avogadro number of electrons. Then we need to multiply this with the Avogadro number. So simply we can say, then don't take this side, 1.6 into 10 power minus 19 into Na. If you multiply with this Na, this will come as a 96500 coulombs or 1 Faraday. It is a 1 mole of electron charge. Okay, right. If you see mass of electron, is very small. It is a 9.1 into 10 power minus 31 kg. It is a very small mass. It is there. And another information about this, the specific charge. What is the meaning of specific charge? Specific charge means charge to mass ratio of these particles. Okay, so charge to mass ratio. So we know charge of electron is 1.6 into 10 power minus 19 coulombs. Mass of electron is 9.1 into 10 power minus 31 kg. If you calculate this one, this value comes as a 1.7 into 10 power 11 coulomb per kg. This is the specific charge of the electron. Okay, and another very important point regarding this one, the specific charge of this electron is same for the all gases. Okay, specific charge of electron is same for all the gases. For all gases is same. Okay, but the same, the specific charge for the proton, that means like a anode rays, is not same for the all the gases. Okay, that we will see about another fundamental particle, that is nothing but the uh, proton, or second fundamental particle we will discuss here, proton or anode rays. Right. So if you see few points regarding this proton or anode rays, it is discovered by Goldstein. Discovered by Goldstein. Next, these rays, so as it is named as a anode rays, these rays are moving from the anode to cathode but not generated by the anode. Okay, so these rays are moving from anode to cathode, anode to cathode, but not generated by anode, but not generated by anode. Okay, it is very important. And another one similar like a electron, this also having some charge but exactly opposite charge it is there. So charge of proton, it is 1 point plus 1.6 into 10 power minus 19 coulombs. It is a positive charge. Next one, mass of proton, if you see, mass of proton is much more higher than the electron, and this value is 1.6726 into 10 power minus 27 kg. Okay, this mass is a much more higher than the proton. Okay, and if you see specific charge of the proton, specific charge of proton, so here the charge is 1.6 in 10 power minus 19 coulombs divided with 1.6726 into 10 power minus 27 kg, sorry, it is a kg. If you calculate this value, it is comes around 9.8 into 10 power 7 coulomb per kg. This is a specific charge of the proton. And very important regarding this, the specific charge of this anode rays is not same for the all the gases. Is not same for the all the gases. It is differ from the gas to gas, as the mass of the positive charge species will be changes as as the gas is changes. Okay, so it is very important. The specific charge of the anode rays, specific charge of anode rays is differ from gas to gas, differ from gas to gas. Then what is this value which we have discussed here? This value, that nothing but the, this is a specific charge of the proton which is in the hydrogen gas, which is in the hydrogen gas in the discharge tube undergo dissociation like a 2H plus 2 electrons. So for these protons only this specific charge we have calculated. Okay, and note that specific charge of this anode rays is maximum for the hydrogen gas only. Okay, so maximum specific charge, maximum specific charge is for hydrogen gas. As it is a mass is very less, it has a high specific charge. Okay, right, this is what some information regarding the anode rays. Another subatomic particle, that nothing but the neutron. If you talk about the neutron, so neutron is discovered by Chadwick. It is discovered by Chadwick. How he discovered? So he bombarded a thin sheet of beryllium with alpha rays. You know alpha rays, that nothing but the helium particles only. When he bombarded like this, he got a carbon with atomic number 6, atomic weight is 12, and he also observed that there is one chargeless particle is generated whose weight is slightly greater than the neutron. And this weight of this neutron or mass of this neutron, if you observe, mass of neutron, that is 1.6748 into 10 power minus 27 kg, which is this mass is slightly greater than the proton. Okay, this is what some information regarding subatomic particles. Now if you see the overall view of this the overview of these subatomic particles, and here this discovered by, I have given the some fundamental particles and the discoverer and year of discovery, and by what experiment they discovered these things, and the relative charge and relative mass. If you observe, electron is discovered by J.J. Thomson, and year of discovery 1897, and this is discovered from the experiment, that is a cathode ray discharge tube experiment, cathode rays discharge tube experiment, and charge of this electron is -1. So but previously what we discussed, charge of this one is -1.6 into 10 power minus 19 coulombs we discussed. Okay, previously we have discussed as a -1.6 in 10 power minus 19 coulombs. So this is a relative charge which I have mentioned here. This is an actual charge. Okay, same like a, this has a relative charge which is a +1, it is there, and you know there is no charge of the neutrons, and relative mass of these electrons, if you see, 1 by 1836, which is a very small size, as very small mass as compared to the proton. Okay, another one, protons, if you see, it is discovered by the again Goldstein, and year of discovery is 1886, and this by Canol rays experiment he discovered this one, and this relative charge is +1, relative mass is 1. And neutron is discovered by the James Chadwick, year of discovery 1932, and how he discovered, as I mentioned you earlier. So he discovered this neutron by bombardment of thin sheet of beryllium with alpha particles. Okay, and charge is 0, and mass, relative mass is almost close to 1. Because protons and neutrons are almost similar weight only we have. Okay, right. So these are some important points also I have mentioned. So electron who discovered, and also so by what experiment they discovered. So same thing that we have discussed just now. Okay, right. This is the some information regarding um, like a subatomic particles. Now if you see a question regarding these subatomic particles, right? So arrange the particles in their increasing order of specific charge ratio. Okay, so specific charge ratio, it is asked this question. So this type of questions very frequently you can see in the entrance examinations. Let us see first one, electron, proton, neutron, alpha particle. First of all, you should understand here what is the alpha particle. Alpha particle is a bipositive helium ions. Bipositive helium ions, nothing but what here. So it is a alpha particles. Okay, this atomic number is 2, and the atomic weight is 4 for the helium particles. Right. Anyway, let us see this one. Right, I'm taking about the electron here first of all. So in case of electron, um, specific charges, I'm taking the relative charge on relative mass only. I'm taking relative charge is which is a 1, and relative mass is 1 divided with 1836, and this value goes to the 1836. Okay, and for proton, so relative charge is 1, relative mass also 1, and this value is nothing but 1 only. And for neutron, you know there is no charge for the neutrons, it is a 0 by 1, nothing but 0. When you come to the alpha particles, as I mentioned you, alpha particles are bipositive helium particles. So helium ions. So this charge is 2, and mass of this helium is the relative mass, nothing but what here 4 units. So it comes as a 1 by 2 will come. So these are the relative like a relative specific charge ratio here. Now if you see this order here, so what is the answer? Right. So you can understand the lowest value for the neutrons. Neutrons is the lowest value, and next is alpha particles. Next is for protons, and the least is for which one? Electron. Sorry, highest for electrons. This is a specific charge ratio for this particular question. Okay. Next question, if you see, so it is given sodium ions, lithium ions, fluoride ions, magnesium ions, and aluminum ions. In this case, what is the specific charge ratio? Let us go with the one by one again, as we discussed earlier. So first one, it is a Na plus. Na plus specific charge ratio is charge is 1 only, and mass of the sodium is 23, relative mass. As you know, it is 1 by 23 only. For lithium plus, so it is a 1 by 7. For F minus, it is 1 by 19, relative charge is 1, and relative mass is 19. And magnesium plus 2, relative charge is 2, relative mass is 24. The simplest ratio, if you see, 1 by 12 will become. Next, aluminum plus 3, like a relative charge is 3, relative mass is 27. Its smallest value is 1 by 9. Okay, right. So when you write this answer here, so what is the order in this case? So lowest value is for the sodium plus, lowest for sodium plus, then it is F minus, then it is Mg plus 2, then it is aluminum plus 3, and highest in this case is for lithium plus. This is the way we will solve this type of questions. Okay, right. That's it regarding this subatomic particles. Thank you.